So we've now solved all the money problems. We have solved the permit problems. It's time to set up the solutions to meeting the audience demand and putting 150,000 QSIS in the log. And we have 3 people joining me who have experience in building remote stations. We have George, the father of the rib, Ned, who has been operating a remote station in Stafford, Arizona for a very long time, and was also very instrumental in rib design. And we have Adrian, who's a master of networks and everything digital here, and he'll talk about proper network designs and cabling solutions and what have you. Whoops, there's no mouse here, George.
Yeah, use the space bar. Just tap on the space bar.
Just tap the space bar, look at that. And as I said, Ned, who has built a very successful remote operation in Stafford, is going to talk about station layout and antenna plans, and we'll take it from there.
Okay, thanks very much. Something that's, people hear me? Am I okay here? Yeah. I like to akin using a remote station is like operating your station looking through a soda straw. You have very, very limited vision. Everything, you have to be able to see everything you need on a TV screen, okay? And I don't know about you, but my eyes are getting experienced and challenged with, as the size of fonts get smaller and smaller, my ability to read anything gets degraded. So you have a mix of trying to get vital information that you need every second, easily available and visible to you, and those things that you need every once in a while don't need to be in the prime location in your view. From human factors side, you can easily scan up and down a lot better than you can scan left to right. And so something that I've learned over time is to organize a display of information so that the real-time data kind of lies on the center line of that display, and that your eyes are, without strain, able to see sort of the middle of the target of the TV screen. All right, and that's kind of the starting point for building a view to a remote facility, is to have the high information content stuff, what you are logging, what is being decoded, whatever that changes very quickly, you want to have an easy view. Something like the direction of an antenna, or which antenna is in use, or what's the status of the amplifier mode, what your log total is. Not as high an information bandwidth, and you can kind of relegate the idle moments of time every once in a while to move your eyes over and look at that. So that when you're laying out the view of your remote station, you park non-high information content items to the left or to the right. There's also lots of cool features in like contest designs. If you use green heron everywhere remote sort of technology, you can have the antenna controls be filtered so that you only have the ones available on the band that you're on right now. All right, so that you can reduce the real estate on your display. You can reduce that associated with controls if you use band filtering and things like that. Something that you do not see on this picture is any waterfall. Waterfalls are not your friend on remote operations. The view that you see is generally the output of a video compression algorithm in order to get of high fidelity image across the internet. The compression technology sort of does they paint the whole picture, And then for a while, they only send updates, all right, what pixels changed, all right? And you know, if a number over here changes or you type in a call and a column of call signs pop up, that's pretty low bandwidth stuff. But a big waterfall chunking away, you know, dropping a new, you know, changing the color of every pixel every second is a very high bandwidth image. And you will pay the price in bandwidth, and your IT guy will choke you to death if you enable a waterfall display on a remote site with challenged network bandwidth. All right, so keep that in mind. You really don't need, frankly, on a DXpedition, you don't need to see a spectrum unless you're troubleshooting. It really gives you no information. Your ears tell you everything you need to know, and your hand or your mouse will find what you need to hear. You're not going to jump to a new frequency on a DXpedition, so you don't need to see where there's a clear channel. If you're troubleshooting an interference problem and you want to figure out what's going on, you need to see the spectrum, and that's really, really handy. But if you do have and we had a mix of views which had, you know, really kind of needed to see the spectrum a little bit because the controls were in the spectrum display and for the flex. But what you can do is you can park a window with not much high bandwidth information over the top of that window, you know, layer it so that the waterfall is, you could see it by moving the window to clear it up, but that you significantly reduce the bandwidth of your video stream if you can stop pixels from changing colors and increasing the bandwidth. So that's kind of the summary I want to talk about. I mean, everybody's, you know, the actual physical stations are going to be whatever is needed to get the job done, but for the remote operators, they are going to see that screen. That's all they could view. And everything that is needed to run the station both locally and remotely needs to be on that same screen. So the local operators need to start to have that same view as well. Now there's another actor in the play that like the Jarvis operation. George was the system administrator. He had his a special display on the boat that had the sort of the status of all of the equipment. He has an application that's running that monitors temperatures and the state of switches, and he can, at a view, he can see that everything is in green and there's nothing for him to worry about, and so but that's not generally a remote operator function, so I didn't bring it up here today. So to talk a little bit about antennas, I know it's jumping from, you know, huge topic to huge topic, but on a DXpedition like these, like the ones that George talked about, where you're operating on the beach area, it's usually a chunk of real estate that's not too deep and maybe as long as the cables you want to carry on to the island. Okay, you rarely are limited in how much beach to use, but if you go, you know, over 1,000 feet, you're really going to be carrying very, very heavy cables on the island, and that may work in some places, it may not work in others. Since you can't build stations everywhere, you have to sort of have a central power plant, and you have, and this is chart that is of the planning phase of Jarvis. It's not what they ended up with, but this is where they wanted to start. To the right of that is where the rib boat landed, or was actually pulled ashore, staked, and the generators are there. That's where your power. All your extension cords start there. And so he moved ribs as far as the extension cords could reach just to get started on separating stations. And there's, to the left of this chart is the most vulnerable antenna, the 160 vertical. He wanted to get as far from everybody else as possible because it's his boat, it's his band, it's his decision, and like any DXpedition, you know, there's going to be a hierarchy of objectives, and getting the good, high quality receive capability of the 160 antenna is very important, and it gets one of the prominent locations on the site. So it's located as far from everything as possible. Something nice about the FT8 and digital modes is they all transmit at the same time, they all receive at the same time. So you can do lots of crazy stuff with those antennas. You can share them if they're multi-band, but we don't have any multi-band antenna. We have antennas that can be tuned for multiple bands, but they can only operate on one band at a time. So there needs to be one antenna for each radio. But you can cluster the antennas very close, because you don't have to worry about interference with each other because they're all receiving at the same time and not having to fight with each other. But you want to separate those as much as possible, and I think those are the ones to the right of this chart are the digital ones, and give the CW and sideband folks as much of a shot at getting some less interference from the digital transmissions. Another dimension is to use the depth of the beach. All of the antennas which require a good ground for performance are towards the water line. Those that have a ground independent have a ground feature like the N6BV series of antennas. So they have a counterpoise that's above ground, are ground independent. They can be further away from the water line, and you get some separation that way. But that's your general rules of thumb. Get your antennas as far away as possible. And the other thing to consider, is to work on a community receive antenna. Maybe a long way from any of this is a single antenna system that can support receiving on every site. I mean, operations on islands, there's no LED lights. There's no, noise sources are what you brought with you. And if you are successful in keeping your emissions of your equipment low, you might benefit from having a single receive system that helps everybody receive on every station on the site. So, go ahead, George.
All right, thanks, Ned. So I want to talk about powering a DXpedition, because really that's one of the key issues when it comes to running a DXpedition. Forget powering with solar or wind, that's not going to work. So you do down to generators. The traditional approach is to have a large generator that will provide enough power for the peak power that you're transmitting. For example, if you're running CW, you want to put out 1 kilowatt, you need to have about 1.6 kilowatts of DC power for a solid state amplifier, which works out to about almost 2 kilowatts of AC power from the generator. That's a fairly big generator, and what you're going to have is a generator that operates very inefficiently because it's constantly revving up and down, because the load is changing as you're transmitting. With every dot and every dash, you go to 100% load, and then in between, it's zero load. So the generator is revving up and down. It will burn a lot more fuel. It's noisy, it's annoying. The alternative is what we developed over some time. That is using 2 small generators, and more importantly, the generators feeding, I don't know if this will work. Yeah, there it is. The generators feed a small power supply. It's a much smaller power supply. It's a 1,000 watt power supply, which obviously could not provide 1 kilowatt output. But where the difference comes from is an ultra cap that stores energy while you're not transmitting. Think of it, you're transmitting CW, your duty cycle is about 40%. So in that 60% of the time, this power supply is charging the capacitor, and when you push down the key, power comes from here and from the power supply. That means that from the generators, you're only drawing 1,000 watts of power, and 2 generators parallel will carry this much easier. The generators are not revving up and down. The load is constant on them, or relatively constant. And of course, 2 small generators are much easier to carry onto the island and move around than a big, huge generator. That's really probably the number one benefit. That is, you really don't have to carry a 250-pound generator. Instead, you carry 2 40-pound generators. And of course, at the end of this, what you'll find that your fuel consumption is as much as 50% lower. can make a 50% difference. Now just think of it this way. A 2-week DXpedition will burn about, with a traditional generator, probably 30 gallons a day, or 20 gallons a day. So 2 weeks, you're talking about hundreds of gallons of fuel. We cut that down to about, we were burning on Jarvis a total of 7 gallons per day. So for 14 days, that's about 100 gallons. So that's almost, let's say, half of what a traditional DXpedition would burn. Fuel, pardon? Okay. So a traditional DXpedition would burn twice as much fuel than what we were able to achieve here. And of course, that's fuel that you have to buy, carry on the boat, take out to the island, pour into the tanks, etc. So this kind of a powering arrangement is very efficient and much better for a DXpedition than the traditional big generator brute force solution.
Okay, I'm going to spend a few minutes talking about IP radios, radios with a IP interface. And the reason I want to talk about that is that some solutions like that, which was needed to solve the Jarvis problem where the radios are on shore and the computers are on the boat, you needed to talk about radios that could operate on a network and not have to be directly connected to a computer. Almost every radio today works through a serial interface on your computer. But if the computer's 2, 3, 4 miles away on the boat, they don't work without allocating a computer in the equipment on shore and then tying it in with a logging system or something on the boat. So a lot of solutions will be looking for an IP device. The radio that's missing here is the IP radio that doesn't have a very, very expensive front panel. I don't show it, but the Flex radio is the only one that has the ability to operate without the need of a front panel interface. I mean, if you've already got everything you need on a computer, why do you need another interface? Why do you need all the knobs on the radio? Why do you need the TV screen on the radio? If you already can do all of that on a computer that's on that same network. So we feel that there is a market for versions of these radios that have no front panel. They really would be very attractive to a lot of new solutions that we are looking for, and DXpeditions and contests that rely on remote participation of the operators. Now, a way of looking at the current class of radios that have Ethernet interface, there's more than these. There are a number of other smaller ones that may or may not, that may be interesting for digital only, but if you want an operation that can do sideband, CW, and digital, these are the sort of the state of the art of today. And something that's very important is, do these radios operate remotely with Vox? And not all of them do. Those that do are indicated. There's a lot of issues with CW side tone. You're going to hear a lot about that later today with Jerry Hull, W1VE, who is making great strides in providing solutions for a very high quality CW, remote CW paddle interface. All right. We can all do logging and do canned messages, but many times DXpeditions or contests, you really need to make special transmissions using a paddle to get the information out that you need to complete a QSO. And at this time, those which are what I'm going to call rib ready, And you've seen the ribs that George is developing, and you're seeing now a new one called the Next Gen 2. Is that the title? That is that the foundation, Northern Cal DX Foundation, has supported its development. It's emerging today. You're going to see it for the first time here today, and the Elecraft K4 was the radio selected for that system. So that's kind of where we are today. I'd still would like to see a K4 that didn't have the front panel as an option. But I think as time goes on, that the radios may tend to look more like commodities, like a lot of things are, which are accessed by web interfaces or remote desktop applications. Supporting those radios are some remote control radio software. Not everything is integrated into logging programs, so many times you have to control the power, or to control the keyer speed or other things. You need to have associated software. Many radios have their own software application. There's a suite of family of products from VE2FSQ, the Win4 K4, for Reyasu, for ICOM, which provide what they call a glass interface. So if you have that application running and you can solve your audio transport challenge with Mumble or Sonobus applications, and you can come up with your remote CW paddle, you can operate your station remotely without any like remote rig hardware or anything like that. There is a total software solutions that are evolving out there today that are worthy of consideration for using IP radios.
Okay. Adrian's going to talk about network development, cabling, and what have you to tie all these things together for managing the remote station and for the remote operators as well.
Well, we live in a very digital world these days, and everything around us is connected and networked. You know, your phone, your computer, your TV, even your fridge. And so the technology behind it could get very complicated. The problem is when you're in the expedition, you have to always follow the main goal, and that is making QSOs. So you want to avoid all the extra work that might be needed to do troubleshooting. Now, if you're an IT expert, you might know how to do it, but still it's time-consuming, time that you can spend making QSOs instead of fiddling with the IT. So here you have a typical diagram, which is more or less what we had on Jarvis Island. For some of you, it might look very complicated. For some of you, it might look very simple. But the idea is that once you did all these testing and you got everything working, you have to keep in account that the simpler the approach, the more time you have for making QSOs and less of troubleshooting. So what do you do for that? Basically, you wire everything, and you use components which are easy to diagnose and easy to replace if something is broken. So, for example, if you use a switch that has a very complex configuration, all kind of settings, and then something doesn't work, you don't know what the problem is. But if you have a simple switch and you say, well, maybe it doesn't work, I'll take it up, put another one. No need to configure anything, everything works simple. Then if you take certain steps to make things easier, for example, label everything. From the simple, okay, I'll use an orange cable here, and a blue cable here, and a red cable here, and then when you have to troubleshoot and you have, 20 wires in front of you, you say, okay, I'll follow the yellow cable because that's the one that, seems to be causing an issue. So a simple approach of just color coding something makes life easier. At the same time, you have a bunch of computers there. As you see, things could get very complicated and carried away. But a simple, even a yellow sticky note put on a computer with the IP address and maybe a password for the computer, in the middle of the battle when you have a lot of things going on, and again, keeping in mind that you have to make QSOs and not play IT, you look at the label and you say, okay, this is the IP address for this computer, and then that makes it easy to troubleshoot something. And the same thing applies for computers. Keep it simple. Uninstall every possible, junk software that comes with the computer and just put exactly what you need. Disable the, updates. You don't need any updates. An update or no update, the computer will work the same way. And you can go pretty crazy thinking that the hackers will get into your computer if you don't put this firewall, that firewall. Well, no hacker would be stupid enough to waste his time getting into a computer. There's nothing to steal from there. So you keep it simple. The same thing, if you go to IT school, they tell you divide the network in so-called VLANs or virtual LANs. That complicates the setup quite a bit. So again, if something doesn't work, there could be many possibilities of what's wrong. But if you eliminate that, things get a lot easier. The same thing applies for the router. You can get a sophisticated thing just because you have it or you know how to do it. But again, in the middle of the battle, you want something very simple that just works. Okay, it doesn't work, I'll just reboot it. Takes a minute, and I'm back in business. I don't have to figure out even what the problem is or what caused it, because the network is pretty simple. Of course, once you start adding other components like the AQs, then that's necessary complexity. What's DAQ? For those of you that don't know, it's in simple terms is you're a mirror to stuff that happens somewhere else. In other words, when you operate remotely from the boat or from somewhere else, you don't know what's happening at the other end. Of course, if the computer works, if you can connect remotely to it, the computer works. But what if you need to know what's the power output? Is there fuel left in the generator? Is the actually generator working? What's the SWR? Well, if you don't know what the SWR is, and you're not next to the radio or the amplifier, and you keep transmitting, that's causing a lot of frustration and smoke, or both. So, you need to be able to remotely tell a lot of things that are happening, and so sometimes you have to add complexity. So, you see there, if you take a look at the network, the red square is what happens on the boat. You acquire internet through Starlink, you have a router, and then a little switch, and from there you connect all your devices. And then you have the short network, the blue one. It's more or less the same thing. You have a bunch of radios, which are more or less computers. They're IP radios, just like was stated earlier in this presentation. And then you have a simple switch and a bunch of computers. Those computers are there so that you can access the network. And then you have those DAQs. And so if you look at it from that point of view, the network is pretty simple. Now, to connect the two together, the two networks, the boat one and the short one, you need something called bridging. What bridging is, it's a way that allows you to simply make everything one big network. So when you start troubleshooting or configuring this setup, it'll be a lot easier if you have just one network instead of two. And so that's what that bridging does. In the past, bridging was a really complicated affair. You needed an IT degree to get that done. But today, companies like Ubiquiti sell you these two devices. You put one on the boat and one ashore, and configure it once, and then that's it. It makes the network as if you have one big network. That makes it, again, very simple to troubleshoot. And so another idea behind it is, to make it simple, is you assign an IP address, a static IP address, to each and every component. So then by doing so and keeping obviously good records of it in the digital format, but also a piece of paper that you just stick to the, your shack there and say, okay, radio number 3 doesn't work. Well, what do? You look at the IP address, which you printed, and you ping it. If it's alive, you know it's alive. And then you narrow down a lot quicker to where the problem is. So the more you focus on simplicity and easily to troubleshoot, the less things will work when you are on the expedition. So again, I listed a few of these items that I just talked about earlier. And so there are many, many other things that you can take into account. But in the end, it's not rocket science. If it was rocket science, it wouldn't be used by hams, going on the expeditions. So a simple item, use static IP addresses. As I said, makes troubleshooting very, very simple. Then you use wired connections. Why? Well, Wi-Fi is great. You are not tied up to the wires, but Wi-Fi only gives the stated maximum speed in a lab environment. What does that mean is that, it's very unpredictable. It's something called jitter, which means you do get maybe, let's say, 300 megabits per second on a Wi-Fi network, but if that 300 megabits is average, and the speed actually goes up and down. Sometimes you get 500, sometimes you get 50. So that up and down is called the jitter. And when you use that network for audio, then things get complicated. That means you lose what the other guy is saying. You might lose a bit, a dit or a dash. And so Wi-Fi is not really a reliable medium to set up as a network. So in that case, you're going back to the basics. You put a wire connection, and if it says 1 gigabit, it will always be 1 gigabit. If it says 100 megabits, it will always be 100 megabits. So you reduce that those issues of delays and frustration caused by jitter. And so wired connections, again, keep in mind that color coding makes it very easy. It's been used for many years, even for antennas. You got 3 pipes, and if they're all labeled red, that they all get together. If they are all blue, then that those get connected together. So this way, you use your brain for other things that might show up during the expedition, because there's always things that will go wrong. But if those are of minimal impact of the expedition, then things will be better. As I said, label everything, especially if equipment is on the boat and the boat moves and one wire comes out, you'll say, what was it? Was it on port number 2 or 5? Or, so if you label it and say blue wire number 2 goes in port number 2, then you don't have to be a real genius to know how to put it back and fix it. Next thing is avoid complex configuration. When you deal with the computer gigs at your work site, or, maybe your friendly neighbor, they always come up and they like talking, using terms that you don't really understand to make them feel better. And it's the same in every company. The IT guy comes with this complex solution that will solve all your problems and make you rich and happy. But in the end, from my experience as an IT guy, 90% of the cases when things work is because things are simple. If you have 3 components that you have to diagnose, it's a lot easier than if you have 13 or 30 of them. And so it becomes easier because then if you have only a few components, then you swap them. If these components have configuration, even if it's complex, you save it, and then when you swap devices, they're already with the configuration in there, so then you don't have to be a real genius to get things working. As I said, you got 3 components, maybe one of them is broken, well, just swap it. Let me change this one, see if it works. Put another one in, but if the network is complex and it has devices with names that you can't even pronounce, you're not going to be able to get this done that easily. Pre-configure spare components. Well, if you need 5 laptops on the expedition, think about getting 7 or even 8. There's always going to be that guy that spilled the coffee on the keyboard, and you feel sorry that you don't have another laptop. And you put the laptop in there and you realize, boy, I got to put this logging software, I got to configure it, put all these details. What CQ zone was this thing? And so you end up spending 2 hours pre-configuring or reconfiguring a brand new laptop. Do that before the expedition, and do something what the experts call fire drills. pretend things break. Be the bad guy, unplug a laptop, and put a new one in. Let's see if the new one actually works without me doing anything else. And that's where pre-configuring the spare components comes in. And that applies for patch cords and switches. If all your wires are, going to your switch, and you put 3 spare ones right next to it, it's a lot easier than looking for those spare wires in some box, which is under another box, and who knows where and what location. And so, small little things, everything that I just mentioned, again, it's not rocket science, are small little items that really make things a lot easier. The network design, keep it the minimum, as I said. Don't listen to the over complexity proposed by those gurus that only post ideas on the forums. Look at the guy that's been on the expedition. Ask him, what's the design that I need to get things fixed in 5 minutes and not 5 hours? Always be prepared. It's not about that things might happen. It's definitely going to happen. And another thing is make it easier so that others can help you troubleshooting. You put a new, a laptop breaks, let's say. You bring a new one, and then you say, how is this configured? Was that window in this corner or that corner? If you make things look exactly as they were before the repairs, things will be a lot easier. And one simple thing that could be done is screenshots. It's very easy to do, and then put that screenshot piece of paper right behind or underneath the laptop. Well, if something is missing, you pull that piece of paper, you look at it, compare it to what's on the screen, you say, look at this, this is what's missing. And you get things done and fixed, again, very simple. It's also very important, and this is one of the items that we put a lot of effort to when we were in Jarvis. Everybody seems to be an expert, and everybody thinks that if they did it one way on their computer, it should be done the same way on another computer in the expedition that's used by 10 other operators. So what happens is you operate today, everything is great, according to documentation. You go to your next shift next day, and things look different. Now, instead of making QSO, you try to figure out what's wrong. Well, what's wrong is the guy before you considered that his approach is better and made changes. So, very simple. Designate one person, make him the boss, buy him a beer, make him smile and say, you're in charge. That comes with advantages and disadvantages, meaning that if something doesn't work, we'll blame you. But at the same time, we will make sure nobody else will touch things. And so if it doesn't work, we know it's you and not somebody else. So you make one designated person as the master, and you give him a helper. The helper comes in handy when you have to change 3 cables. And so this way, 2 people changing or replacing those components will be a lot faster than one person. Also, the person in charge sometimes may have to sleep or go to the bathroom or be busy with some important phone call or who knows what. There's always need for some backup person that you can ask him, where's that spare computer? Where's that spare switch? And so the best approach is one master and a helper. That worked out for a lot of the expeditions that I've been to. And one important item has been overstated, but that's the one that causes most of the issues in the expedition. People do not test things. As George was saying before, and his slide earlier showed that he's been to close to 10, almost 10 other expeditions and testing things before we're able to put up a good show at Jarvis Island. Why? Because testing, it's a very complicated affair. Testing doesn't mean that you connect things and they work and boom, you make a QSO. You have to ask yourself, well, what happens if power goes out and all the equipment gets rebooted? Will that bring everything back? Or there's something that needs to be done to get that accomplished? So testing means You unplug everything and see what happens. Then, based on that, you make a plan of what needs to be done if this happens when you're on the expedition. What happens if somebody that considers himself an expert deleted something, or reconfigured the computer with a different IP address, or a computer that we thought it's a spare is actually not a spare. Has been maybe it was a computer that had other components that need to be used for something else. What if somebody wipes out some important program? How do we reinstall it? Well, you just double-click on it and it gets reinstalled. Well, if life would be that easy, it would be a lot easier to put up the expedition to remote places, but it's not. So testing will take probably a lot more time than the expedition itself. Some of these remote island expeditions to faraway places take years, I repeat, years of preparation and testing. You come up with all kind of scenarios, and the more scenarios you come up for testing, the more chances that you will be ready when the battle is on, when you are on the expedition. And remember always that the most important part is to make QSOs. Do not ever forget that, because you own the island for maybe a week or two, and you don't have all the time in the world to get things done and figure things out. So that's basically following these small, easy steps. You will ensure a lot more success than if you do not do that.
Thanks, Adrian. Now you're all set up, you're running. You can be stopped in your tracks by local noise, sometimes your own doing, and George is going to address RF noise on the island. Whoops.
Tomorrow there'll be a session where I will talk more in detail about noise, but noise is a major issue because so much of our equipment today is digital, or the power supplies are switch mode power supplies, and they generate noise. And a lot of the expeditions promise to work on 160 meters, and they're going to be active on 80 and 160, and then the next thing you see is the announcement that, oh, we are fighting noise, and it just goes on. I know of some of the expeditions where they announced happily on the 11th day that, oh, we finally solved our noise problem. Well, noise is something that's going to happen, and you will have noise, and it's guaranteed. So you better start thinking about resolving your noise problems before the expedition, long before the expedition. It's a very expensive time that you're spending on the DXpedition, and you better spend the time making QSOs rather than chasing noise. And noise is in several forms. There is noise from power supplies and other equipment. There's interstation interference, and there is also just noise that is caused by poor cable layouts, where one cable couples into another, and you get interstation interference, not through the antennas, but through the wiring of the system. And your number one friend is preparation. That is, you test every piece of equipment before, but here is a very tricky thing. Long time ago, before a DXpedition, I took a generator out to my home station antenna, right next to the antenna. I started the generator, went into the shack to listen, is there any noise? No, it was quiet. No noise. Oh, great, this will be fantastic. We got to the island, turned on the generator, there's this noise. What happened? Well, at my QTH, I have like 20 dB higher noise than out on the island. And that generator that sounded perfectly quiet back home, on the generator was a very noisy piece of equipment. So you really have to test it under realistic conditions. And tomorrow I'll talk about some of the tricks we used to think, but to test things. But the most important thing is Do it before you go. Once on the island, you have a number of things you can do. Your number one friend is grounding. Not everywhere can you reach the salt water, but if you can reach the salt water, it's a fantastic ground. We use aluminum stakes that we drive into the ground. Forget about copper-clad steel, because it's anyway too heavy. It has to be carried onto the island, and it will sooner or later start corroding. Aluminum is the best. Aluminum stakes you can drive anywhere, they're light, and they're strong enough. Filters and chokes, prepare them in advance. We have a choke kit, a box about this big that we carry that has all kinds of ferrites in it. And the thing about ferrites and chokes is that you put on about 50 in different places. You don't know which ones really work, but the ones that work can make a big difference. And you just put them on everything and hopefully they'll work. And then of course, as Ned mentioned earlier, station layout is extremely critical. That is, you put the generators closest to this, or wherever the generators are, it's more or less a given. You put the stations that are noise tolerant, like FT8 near the generator, then the 160-meter station, probably the furthest away. And then you lay out the stations that they will have minimum interference, or minimum interaction, but also like coax cables. Don't run them parallel. Run them far from each other. If they have to cross each other, bury one of them, put a lot of dirt on top of it, and then run the other one on top of it at right angles. And that hopefully will prevent noise coupling. There are many techniques that you can use to cut noise, but you will waste a crazy amount of time if you're not prepared well in advance. You can spend more than 50% of your time chasing noise.
Whoops. Okay. Questions? I know we have one over there. Yeah. We have a microphone?
Have you experienced RFI issues with all the Ethernet cables and kilowatt amplifiers?
Yeah, so yes, the cables that we use are shielded cables. Before shielding, we had issues. Now we use shielded cables, and wherever there is a long run of cable, it's far away from the coax carrying RF, and the coax has chokes on it. There's inline chokes on the coax to prevent the current. It's really the current that is on the outside of the coax that couples into the LAN cable. So just keep them separate, put chokes on the coax to prevent currents from building up, and use shielded Ethernet cables.
Yep.
Is this mic on?
There's a switch. You have to push up on the switch.
He told me it was on.
Yeah, give your name and call sign when you ask a question.
Rick, N6RK, is it on?
Just keep loud.
Nope, it's not.
Let's just go QRO.
Okay, Rick, N6RK, on one of the slides, you literally showed two small generators connected in parallel to make a big one. I don't see how you can combine generators by just connecting them in parallel. Could you go into more detail about that?
Sure. Certain generators have paralleling features. The Honda 22i, EU 22i generators come with a paralleling kit where the paralleling kit will cause the generators to be in sync with each other, and therefore you can happily parallel 2, 3, or even more generators. The important point is these are inverter type generators. So you don't have to synchronize the engines. You're synchronizing the inverters.
Okay, thanks.
Sure.
Adrian, do you advocate testing while exhausted? Again, it's like not testing when you're at your best.
Repeat the question. Repeat the question.
Yeah, so the question is testing when you're exhausted, not when you're at your best, which nothing goes wrong when you're at your best.
That's all right. We use hangovers instead of exhaustion.
Yes? No, it's dead.
We have now been discussing the technical aspects, but we must also, I'm not a DXer contestant, the biological aspect, to get the group working together so that the members of the group know each other and have confidence in each other so that they can also take the hard cut. Because after all, this is about having fun. Also to be able to have fun on in the contest or the expedition.
The question is team building, which actually is our whole next segment. And your comments are right on. It's have fun and work together, which we'll do in about 6 minutes. Yes.
Israel, it's Adrian. I guess my question is later. Which operational system do you use? Windows, Mac, and also do you use VM, virtual machine, or containers?
So the question is what operating system to use in the expedition, such as Windows, Mac, or Linux, and if we used any VMware system, virtual machines. Well, I'm a proponent that the less money you spend on equipment, the better. And so the Windows machines you can buy for almost nothing, and everybody's familiar with Windows, and so Windows is usually the winner. I remember on the expedition you have the expert computer guy, the expert radio guy, but not everybody else is an expert, so you have to keep it simple, something that everybody's familiar with. And also, most of the logging software for the ham operators, the vast majority of them work well just in Windows. Of course, computer tech can make things work no matter what, but remember again that you have to keep it simple and inexpensive. You get a $300 laptop that has an Ethernet port, you put N1MM, free login software, and everybody knows how to use that. If that breaks, you throw it away, get another one. You don't want to buy let's say, an Apple computer that's $2,000 and, increase the cost of the expedition. Linux is a great system. You can, run rocket in space with it, but if you ask everybody in the room here who is familiar with Linux, I doubt more than a couple of hands will go up. So we keep inexpensive computers, simple setup, no virtual machines, and simple to use Windows. That makes it, checks all the boxes.
We have one way in the back.
Not a question, but a comment. I would caution not to cheap out too much on your Windows computers. There was a top DXing that had all network PCs that were really crappy, and they were losing queues because the computers could not do enough. Get spots, talk to the other computers, decode FT8, write the things to the log. So 300 might be your low end. Don't go any lower than that. And maybe 4 to 5 might be a better price.
Yeah, all our Jarvis computers were current, and they were all ThinkPads, right?
Lenovo ThinkPads, yes.
There were Lenovo ThinkPads that had plenty of grunt.
Right.
And, you can buy $600 radios, but you don't take those usually on DXpeditions. So same kind of thing with some computers.
Thank you. Okay, we're going to take a short break, and team building is up next.